as we start traveling again. But let's go ahead and get started. We're going to be covering relationship fitting today. So I'm going to go ahead and share my screen for you all.
And hey, I started the recording, just FYI.
Oh, awesome. Thank you, Caleb. All right. Can you all see my screen? I am in our latest release. So note that 4/9/2020, and I will be utilizing our ribbon bar interface here. So if you are in a release after, I think it was 5/19/2019, or just May of last year, you have access to this new user interface, and I would highly recommend transitioning to it if you haven't already. To do so, you'll just be going into your user options. It's also that gear icon in the classic interface. Under the display tab here, there's a little checkbox, show ribbon bar. If that is checked, you'll be in this ribbon bar interface. If you uncheck it, you'll go back to what we call our classic interface. And then when you do switch between our two interfaces, you will have to completely close down SA and reopen it, and it will reopen into the designated interface. Just wanted to mention that if you guys have not already switched over to the ribbon bars. So today we're going to be covering the relationship fitting. I will be utilizing a sample file so that you guys can follow along with me either now as we go through it, or if you want to watch the recording later on, because this will be recorded and posted on our YouTube channel, in addition to all of the other webinars that we've had so far. So to get going, let's go ahead and go to our Help tab and going into our sample files. I'm going to be using our relationships sample file. We just select that. I don't want to save this file right now. It's empty. Anytime you do use one of our sample files, this window will pop up. Don't worry about it. Just hit OK. It's just telling you you're using a sample file. So this is what you should see when you open it up. I'm going to change the rendering to solid here just for personal preference. But you can leave it in wireframe if you'd like. So in this file, we have our collected data, our CAD, I believe we call it a hydro deck, our hydro deck CAD, and a couple of planes here, so SA geometry, as well as our instrument that was used to collect the data. So in this file already, there are relationships created. I'm going to go ahead and delete all of those from the get-go because we will walk through the process of creating them and then using them for this alignment. So I'm going to right-click on my relationships and delete all for now. And if we can see, you can see it listed in your point groups. We have 5 different point groups here, and that's designated by their color in this graphics view. So we have the red, just the canopy, purple, the top aligned to this surface, blue or the sides, and then we have our green points going with this bottom plane, and then these pink points going to this green center plane. So if you are using a pro license, you can use relationship fitting, but you're limited to one relationship at a time. So let's first walk through that. We're going to use all of our points that are of this part and the CAD itself to create that relationship. And to do that, we'll go into our features tab. And let's name this first relationship the whole part, because we will go through and create others later on when we're going through how to use multiple relationships. Call this relationship whole part. And if we go into our relationships category over here under points, we have a groups to objects option. So if I select that, it's going to prompt me to select the groups I'd like to use in this relationship. So I'm going to select my red data, this canopy data, the purple, which is the top, and the blue, which is the sides. And you can see all of those highlight over here in our tree as well. I select enter. It's going to prompt me to select the objects. I'm going to select our entire model here and hit enter. And we now have a relationship for that whole part. If we hit this drop down and select our relationship, you can see the deviations here. We do have some obviously large deviations as we're not aligned yet. This is just the relationship right now as a whole. I'm going to go ahead and add a vector group so we can see that adjust as we run the fit. And to do that, I can either right click and go to properties or just double click on this relationship and select automatic vector group creation. That's now created a vector group for all those deviations. Of course, right now they're quite large because we have not run this alignment. Now, if we go ahead and run our alignment, we're going to be going to our alignment tab. Under alignment optimization, relationship fit. We'll be moving objects by minimizing relationships. However, we will be moving our data to our object itself, the object being the CAD, not our CAD to the data. So right now I'm not going to select anything. I'm just going to hit enter, and it's going to prompt me to select my instruments to move. Now I'm going to go select my instrument that measured our data and hit enter. We now get this window pop up. This is our minimize relationships window. We only have one relationship listed right now, and it's giving us our deviations. So now I'm just going to hit run optimization. And that's going to try to optimize the fit of all of that data in that relationship to that CAD. And it's gone. Here, let me update the translucency. I'm just right clicking on the CAD itself. We can see into the part and see the direction of those arrows. So we just got a nice fit. It's brought us down to the 3 thou max. It's listing our translations and rotations here in our motion components. And it's given us a nice fit. So that was just using our run optimization. You do see this other option below it, run direct search optimization. And that is a little bit different here. It's a little more extensive. Run optimization uses the starting point of your data, where it is at that point, and just kind of moves it until it gets that best fit to your CAD. The run direct search optimization will take it from that starting position, find the best fit, then move it again to a new starting position and find the best fit and continue that process until it's happiest that it's found the best fit there. That can take a little bit longer. So if you hit cancel at any point in time, it will just take the best fit to that point. And that is very handy if you have a part that's pretty symmetrical or it fit upside down for some reason. It'll just reset that starting position to avoid any kind of local minima getting trapped there. So with this part, it's had a great starting position just right above the part itself. So if we select that, probably not going to get much of a better fit. But you can watch as it's finding that fit and going through those direct search. Again, we're at 3 and as a max with an RMS of 1. So same fit there. So we just apply that transformation. We are now aligned to our part using that one relationship. If we do want to see some details on our vectors, we go into the properties there. My personal preference is tubes. I'm going to drop down that blotch size a little bit and show some colorization, giving our max and minimum deviations there. And the max is 2 thou, minimum is -3, so this is a great fit. But just to give us a nice visual of those deviations. So that was running a relationship fit using only a single relationship. Let's go through and talk about how we would do it with multiple relationships. I'm going to go ahead and hide these vectors right now. And we're going to create some more relationships. So we'll do one for our canopy, these red points to these surfaces right here. One for our top surface, so these purple, this top surface, and then one for our blue, the sides, as well as a relationship for the center line and that plane. So let's go back to our features. So we'll be creating our relationships. Let's do our canopy first. So now we'll go back over to our relationships category under points. So now we'll be doing groups to CAD faces because we want to select specific CAD faces, not just the entire CAD model as a whole. Select our group, red data points, enter, and then I'm going to select these two surfaces. You can see those highlight as I select. We now have a relationship for canopy. Let's do the top. Once again, doing the groups of CAD faces. Select our purple points and this top surface. And then lastly, for our CAD surface, our sides. And I'm going to be renaming it points, groups of CAD faces, selecting my side point group, enter, and then selecting these two CAD surfaces. And enter. Now have an individual relationship for each of those. And lastly, let's go ahead and get our two planes. Plane. And this is going to be a group to object, since this isn't a CAD surface itself. These are our green points. Then center line. Again, our to objects. As a plane, points along that center line. All right, so we now have quite a few relationships created there, and we will utilize those to get the best fit possible. So again, let's go to our alignment, relationship fit, objects by minimizing relationships, not moving my CAD to my points. I'm going to move my points to my CAD. I'm going to hit enter here because I'm not selecting any objects to move. I am going to select my instrument to move. And it'll bring up this window here, now listing all of the relationships we've created thus far. I'm going to go ahead and deselect the whole part because I just want to use these dissected groups. And so a few things to note in this dialog box now, since we do have multiple relationships, they're all weighted as one, giving them all an equal influence on the fit. But to note, point count in each relationship does have a large effect on their influence on the fit as well. So let's say one relationship has 2 points and another has 20 points. The one with 20 points has 10 times the amount of influence on that fit. What we want to do, that's normally not what you want. So what you want to do is normalize the weighting. So to do so, we go up to normalize weighting. We have 5 options here. Center one is reset all to 0, all to 1. So that's if you updated, changed any, only set once. These top 2 were our original options, just normalizing on the equation count and tolerance width. Then these bottom 2 were created more recently. They are a little bit more advanced mathematically and will give you a little bit better fit. So, but we will never take out anything out of essay that could be being used by customers from this point forward. I'd always recommend using these bottom 2. Lies on this root of the equation and on this equation and so right now we haven't set any tolerances on our relationships quite yet, so we're just going to use this top one. We will walk through the process of creating tolerances or adding tolerances to the relationships and utilizing this bottom one will create the relationships that have tighter tolerances, but heavier, that they have been. Right now, we're just going to use this fourth one down the list, normalizing on this equation count. Okay, you can see these numbers updated. So now with less points in it, have a larger weight. And we can see the center line has over 4-inch deviation right now. And this is the same file that I'm familiar with. There is not the greatest data in that center line group. So we can also go in and project outliers here. Let's first just go ahead and see what this fit looks like. We can run it. I just run the optimization. That's brought these errors up to almost 50 thou, 20 thou, 50 thou, which in my eyes, in this kind of part, these are the data. This is the data. The data to add itself. These planes help us give us more information, but not quite as important in the overall fit. So let's go ahead and project some of these outlines. That's symmetric. Good. So 30. Selected that, and then I run the optimization again. It's now brought these back down. We have just under 4,000 for our canopy. Our top is at just over 5,000 on this side.
Hey, Anna, we're having just a little bit of trouble hearing you. I don't know if it's your microphone or what, but as you lean closer to your computer, it is sounding better. So I don't know if
Okay.
it's just, yeah, that
I'll
sounds
try to
good right
keep my
there.
head a little bit closer to the computer. Sorry
That
about
sounds
that, guys.
perfect. Yeah, that sounds perfect.
All right, wonderful. Thanks, Caleb. All right, so that was utilizing our reject outliers tool. So right now, if we do want to focus on our canopy top and sides, we can just deselect those options or those relationships right there. And now we're only utilizing the canopy top and sides. If we want to renormalize, we can. It's now updated those weights on equation count. We run the optimization again. It's now brought those deviations down to 2, 1, and then 3.5. Overall, a great fit. But let's say we do care more about the canopy and less about the side, so we have some tolerances that we'd like to apply. If we right click and add a tolerance, let's say for our canopy, we want our tolerance pretty tight. Let's give it a 2 thou. Set all, high and low. Okay, let's give our top 5 thou, a little bit looser and still pretty tight. And then the sides, let's give that a little bit of a looser tolerance at 10 thou. Okay, so now we have the option to normalize weighting with this on the square root of the equation count and the tolerance width. So it's going to weight the relationships with tighter tolerances a little bit higher. We selected OK. It's now updated these numbers again. So our canopy is at over 102, top at 31, and our sides at 14 for their weights. So if we look at these numbers right now on the deviations, we're at 2, 1, and 3.5. So right now, this would be out of tolerance. So we run our optimization again. That's now at 1 thou, just under 2, and 4 thou. So that's taking a part that originally would have been out of tolerance if that tolerance was in fact 2 thou. And by weighting it to take those tolerances into consideration, it's now brought that part into passing. So a great tool to use there. Let's see, we've got about 10 more minutes. So one more thing I'd like to cover real quick are the options for degrees of freedom right here. So if we wanted to use our planes again, you can control what degrees of freedom the fit adjusts or the fit controls as you do it. So if we have these selected right now, let's bring this all back to 1. And let's say we want the center line to just focus on this X direction. We can uncheck all of these. And run our optimization. Oh, we still do have outlier rejection, I believe, here. So right now we're over 1/4 of an inch. We run that, we're now below 2, but again, this data is not the greatest, but you can see it shifted over to the left there along that X direction. Now if we add in the plane and allow that to just Z, it's now moved it in those directions, but these are going to give us not so great numbers for our canopy top and sides. But it is a great tool to, if you do want to constrain it in how it fits, you can utilize that. Our data for our center line and plane in this sample file isn't the greatest. So let's go ahead and normalize on our equation count and tolerance to give it full range, get the best fit possible, reselect all of our degrees of freedom there, run our optimization, get our best fit possible. So we're at 1, just under 2 thou, and a little over 4 thou for our max deviations, and apply that transformation. Now, since we still do have this vector group for the whole part, if we view that again, it's going to give us a nice visual on our deviations there. And that's the basics of relationship fitting, with just a single relationship as well as multiple. So we have, let's see, 7 minutes for any questions if you guys have them. Feel free to unmute yourself and ask away. Let's see. Well, if there's no questions, you can also, if you think of anything later on, you can email me at anna@kinematics.com or contact our support line. And this video will be posted on our YouTube channel as well, if you'd like to take another look at it. And all of our other webinars are also there. So Caleb, I know last month did one on other types of alignment. So if you're curious about any of those, that's another great resource.
Yeah, so just like Anna said, the relationships are just a fantastic way to sort of optimize your fit. And I think one of the things that this example shows is that when you're dealing with a complex part that has multiple tolerances, you know, your fit can be really critical to getting the part either passing or failing. And so as long as you have the freedom to align to that part in, you know, the best possible way, then it's great. This is a great tool to just be able to optimize that fit up so that you're not, you know, rejecting a part that should be passed or, you know, passing a part that should be rejected. So those are all like really good tools. We kind of at NRK, we kind of refer to this relationship fit as the money button. So for really high volume, large volume, high tolerance. Sorry, my dog's found a squirrel and are going after it. But for large volume or really high tolerance parts, it can make the difference between you know, passing or failing. So, and like Anna said, if you do need any help with any of these things, feel free to give us a call or send us an email. I'm Caleb at Kinematics. Richard is Richard at Kinematics, and we would love to, any of these issues that you're working on, just be able to walk you through sort of a setup that makes sense to your particular application. So let us know how we can help.